Now we're going to look at the density formula found in the equations box on the first page of your reference table. Now I know you're all very familiar with the density formula, but we're just going to use this as a way to guide us through the steps we would normally use in calculations and how we might manipulate this formula to determine a mass or a volume depending upon the information we're given. Now let's remember what density is. Density is the packing or the concentration of mass in a certain space or volume. So the mass, of course, would always be given in some units of grams, kilograms perhaps, or just regular grams. And the volume is always given in some measure of space, which might be cubic centimeters or even milliliters. Those are probably the most common we would encounter. Since the two units in the numerator and the denominator are different, when we calculate the overall density value, we keep the two units. So we have this kind of combo unit of grams per centimeter cubed or grams per milliliter that would be attached to our final answer. So let's take what we know and run through a sample calculation. Here's a question. Determine the density of an object having a mass of 83.6 grams and a volume of 20 cubic centimeters. This is very straightforward. Okay? We are looking to figure out the density. They give us the mass and they give us the volume. So we're just going to plug in our numbers in the appropriate place. We always start every calculation with our formula. So density equals mass divided by volume. Now we plug in our numbers. Mass was the 83.6 grams, and yes, please remember to always write your units. There are no naked numbers in this calculation. The volume is 20 cubic centimeters. We do the arithmetic, plug it into your calculator, you punch in the 83.6, hit divided by 20, and you wind up with an answer that reads 4.18, which would be grams per centimeter cubed. Now we're almost there. We've got the correct arithmetic answer, we've got the correct units, but the other thing you're always asked to do is round your number. And unless you're told to do otherwise, the standard is to round to the 10th. The 10th place is one place to the right of the decimal. So that means that I need to look at what is in the second place to the right of the decimal to decide what to do. In my example here, 4.18, I see that the 8 is greater than 5, so that means that it's going to cause me to round up that 1. So my final answer is 4.2, right? I rounded up that 1, grams per centimeter cubed. So there's our final answer. Very straightforward. Now, the only thing gets a little bit more involved is what if we don't have mass and volume, and they're not asking for density, maybe they're asking for a mass, and they give us density and volume, or they're asking for a volume, and they give us mass and density. Some students might get a little bit concerned about having to work through the algebra. It's not that bad. Let's see how we do this next example. Number 2. What is the mass of an object having a volume of 33 cubic centimeters and a density of 4.5 grams per cubic centimeter? So here's the change up. This time we're looking to figure out a mass, but they give us the other two important known quantities. volume of 33 cubic centimeters, and the density of 4.5 grams per cubic centimeter. We're still going to use the density formula, and we'll plug in what we have. Density equals mass divided by volume. Okay, rather than start to play around with a lot of algebra in my head, I'm going to set this up as a ratio. Because remember, any number over 1 is itself. So I could put that density over 1, and I haven't changed anything. But I now set it up in a way that I can plug in my known values, still have one unknown, do some cross multiply and divide to come up with my answer. So let's do it. Let's plug in what we do know. We know the density. It is 4.5 grams per cubic centimeter. Okay. That's going to be over 1. Equal sign. What's on the other side? The mass is what I'm interested in finding out. So that's going to be my unknown. My volume is 33 cubic centimeters. So I'm going to plug that in right here. 33 centimeters cubed. Now when set up this way, and all your units are written in, you can see what you will eliminate, what you will cancel out. Centimeters on the bottom, centimeters on the top will cancel each other out. There's only one unit you are left with, and that is grams, and that's exactly what you're going to want for a mass. Let's do a little bit of cross multiply. 1 times m gives me m, okay, mass. 4.5 grams times 33 gives me 148.5 grams. There I am. There's my answer, 148.5 grams. Rounded to the 10th with the proper units, correct arithmetic answer, and it was no trouble at all, even though they switched up what we were asked to calculate. So this is a good starting point for us to follow through with units, with rounding, with calculation, and of course with always writing our formula to start to take us through the problem. That should do it for now.